Hello, and welcome to the Network AutoMagic show. I'm your host, Steinzi, and I will be taking you on quite the journey today. We're going to have a special guest on named Ryan Shaw. He's going to tell us all about how he uses Temporal to automate networks over at Zscaler. Joining me is my Swiss trusty co-host, Urs, and we are going to have quite the show, so please enjoy this inaugural episode. Well, hello there, listener. Welcome to the nondescriptive, we haven't decided a name for any of this, but we have a special guest. It's me, it's Urs, and it's Ryan Shaw from Zscaler. His opinions are his own, and I'm going to let him introduce himself to the wonderful listener. Ryan, could you tell us a little bit about yourself?
Yeah, sure. I am a network architect at Zscaler. I've hopped on a few companies. I was at AWS for a while, went to Imperva and Salesforce, and now I'm here at Zscaler, helping out the architect team.
Awesome. Now, the reason why we wanted to talk to you today is to extract free consultation services from you in the guise of an interview. But what we're really just trying to do is pick your brain for stuff to steal and pass off as our own ideas. So, Temporal. You've been very religious about this at a certain Slack channel that won't be named, or maybe we'll name it. Maybe you give us a backstory of like how you got involved with Temporal.
Yeah, sure. So it was pretty much happenstance. I was trying to build out my automation platform, and being that I am not a professional SE or anything like that, I know like building out orchestration, service is pretty complicated. So I was trying to find some areas, some sort of software to do it, and I was looking at like Airflow and a couple of the other kind of DAG workflows and such. They're open source. And then at Salesforce, we had a security, review process and stuff like that that can be quite lengthy and cumbersome. And I found that Temporal was one that I was looking at, and Temporal was already used. And so I was like, oh, cool. All right, I can just go with this. And it's already passed through, been vetted by security, and other teams have used it and kind of picked their brains on it. So that's how it came to fruition. It was the easiest through the gates for security. But afterwards working with it, I'm kind of glad that it was that case.
All right. So you mentioned some other, DAG style workflows, and I mean, for our listeners who isn't familiar, Temporal, right? It basically guarantees durable execution, right? That's the big sales pitch, right? That you kick off some sort of process or a workflow, that contains some activities and that sort of thing, and it goes from A to B, and you don't have to worry about as much the filling a single Python script with try catch statements and leaving it running on some random server in the middle of your organization. You have this execution framework called Temporal, and you're able to orchestrate basically, these tasks that you want to accomplish. Is that right?
That's perfect. Yeah. So with like other ones, you have kind of state you have to keep track. It's usually on a single host, and if that host failed, then you have to either recreate the entire workflow, find out what state you're in, or add some complex stuff that you have to keep that whole thing running well lubricated. Whereas Temporal has that in its base form is that it is stateless, and it has the server keeps track of the state into it. So you have the workers which do the work, but they're all stateless. So a worker could die, it could fail, it explode, spontaneously combust, and you can just keep on trucking.
So this was your key point that you decided to go with this, or what are the other features you love about Temporal?
Yeah, so I'd say the key points was durability, definitely a thing, because it was something that would have been outside of my wheelhouse to code, or know how to manage, or like with other tools to kind of wrap that around. But mostly it was kind of the flexibility of things. With Temporal, it's definitely not a no code or a low code; it is all code. But that flexibility is just wonderful, especially when looking at networkings and rollbacks and stuff. A lot of other ones are assuming that everything's going to work perfectly. There's always a happy path, or like pipelines, CI/CDs. Like it's just one branch, right? Like there's no like, hey, what if this? What if that? Whereas Temporal, since it's all code, and you can do if statements and stuff like that. Hey, if this works, or errors, and do this if something fails. That flexibility allowed me to really align myself with the networking runbook process of, hey, this worked. Oh, it did. run these set of steps instead. And that was really, kind of the main goal why I used it.
So, jumping from maybe the standard DAG happy path, as you said, which is, a directed acyclic graph, meaning there is no loop. So if we're sitting in our car right now and we're imagining a workflow, state machine, check light A, and then if it's green, then do this. If it's red, then do that sort of thing. And you can loop and come back to original parts of the execution. Is that what you were able to do, or?
Yeah, so it's still very much DAG like
Mhm.
that. Most of your branch is not going to, still going to be acyclic.
Mhm.
But you definitely can loop and redo workflows and re-trigger stuff, because again, it's all up to your code. Like you can rerun the process how it is. It's very flexible, so it allows you to do, probably the majority is still DAG style, but it allows you to do other stuff. That would be constrained by normal DAG workflows.
All right. So, when we, think about normal DAG workflows, I mean, most of us are familiar. Well, you would see Apache Airflow or Dagster, all this stuff, and everyone has their special niche, and everyone's being an AI company these days, and they're all going to help train your LLM data sets and blah 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 blah. Like having they reviewed a lot of the information about Temporal. It seems like they're very much coming from DevOpsy slash back end, very cloud people-y. This does not reek of network engineering 101. I didn't see a single CCIE in that crowd in that video. So what type of workflows, if you were going to sell Temporal to like your run-of-the-mill network engineer, what type of workflows do you think would fit really well into the temporal execution framework?
Yeah, it's a good point, and it's something that I've also trying to drive too. Is Temporal was not built for the infrastructure at the start. Infrastructure people have used it. NVIDIA uses it for their infrastructure, and there's been other companies that have done presentations for their infrastructure use cases. But it's primarily started as a software, right? Like for software-driven workflows, to handle between processes and microservices and such, to handle the kind of those durability and long-running executions. Um, I was coming at it from just, hey, I want to run this runbook. Like, let's say I want to deploy config, right? So I want to make sure I have the config, that I grab the right set of configs that I want. I want to make sure like maybe the diff looks good. Maybe I can have a human manually approve the diff, and then it goes on to the next stage. And then I can run some pre-checks, make sure that all the devices I'm deploying to around or siblings are healthy. Do the config, maybe remove it from service with a drain, deploy it, check again, undrain, return to service, update tickets, all that stuff. I can do that with Temporal. So it was basically, I'm using it primarily as a DAG, but I'm using it as a very flexible DAG, if that makes any sense at all. So my use cases are very less system software service, and more of infrastructure as a code kind of systems.
Right. So less, Azure driven, cloud opsy, whatever, DevOps. DevOps is a meaningless term these days anyway, so we can't even use that word anymore. But, more, closer to the metal, but, still abstracted away from the, every single command line type of workflows, right? So, you would be combining this with other libraries, and we'll maybe get into that in a bit about, how Temporal is just an execution framework. Like it doesn't even, yeah, I mean, or how the system is set up, you can have any code running in there. So it's Java, it's Go, it's Python. You can probably even mix and match in some cases, I would believe, because I've seen terrible things running on this cluster so far. So I was able to get some Java running and then some Python running, and I was just going, so long as you have a worker for this thing, it seems to just pop out on the other end. So I believe you're a Go shop, right? So anything special in particular that led you to going Temporal Go?
Um,
Pun intended.
so
Go Temporal.
yeah, what led me to going with Go? Uh, uh, Not really. I mean, more of the fact of the previous teams, the companies work with were already using Go, and so to just align with those existing services and existing, because as you said, it's execution framework. you use it to then use your code to hook into other services as you wish. And so those services were in Go, so I just recreated a Go. I haven't looked into the Python or Java or TypeScript aspects of Temporal. I do know a lot of the backend stuff works really well with the Go version. I don't know, for listeners that are not really familiar with Go, there's two things that I really like about it is Go routines. And it's like just pure green, threads. And then there's a function called defer, which is after the function, it does any cleanup work. And, Python, there's, like the file opens of like, hey, you do the with open, and then it automatically closes the file after you're done. And Go is you open the file and you can defer file close after the function ends, it closes that.
Mm-hmm.
What's really
so
nice
last one out shuts the lights off, basically. So last one alive shuts the door.
Exactly. And so what's really cool I learned is because I need a lot of rollbacks and, hey, if something fails, do this. There's a pattern called the saga pattern where I can just include that all in defer blocks. And so I don't have to create, this dynamic, set of steps like, oh, if it failed on this step, do these 3 steps instead of do these 4. It goes, okay, well, here I'll just run all the defers that I've known. And it's because defers run in the reverse order, it automatically orders it. So it's a really kind of clean, elegant solution. But those are kind of the two are like, oh, that's nice. I don't need to run any threading. Like it's gRPC and stuff, so it automatically does Go routines, and it's quite nice with that. But as you alluded to, it's a polyglot language, so you can have workers running Go, activities running Java, and your client running JavaScript. It's all protobuf in between, so you get to have those language interactions.
And you don't have to take care of the monkey framework, doing the monkey plumbing, basically running around with a wrench trying to tie together different scripts and that sort of thing. So you get this, wonderful event bus basically with gRPC, and you're able to send things back and forth between the workers. And now for our listeners in the car, whenever somebody asks you why you pick Go, you always go with, well, the parallelism and the concurrency model is excellent. And also I find that the compiled language actually blah, 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 if your data inline, so, this is for the kids, right? It's data inline, you go every single time. If you're taking in 20 gigs of data, always go. If you're just doing stuff, then Python is your friend. Java's gross. And, I'll fight you in the parking lot about that one. But you mentioned workers and activities, right? So, workers, if you could give the difference between a worker and an activity, and maybe talk about the deterministic fact of a workflow, which has to, every time you put an A as an input parameter, you're supposed to get the same output parameter, right? Versus an activity, I assume that would be something you would use to connect to external services that may, give you an A or a B or something else back every single time. Could you tell us about that?
Yeah, so let me they're definitely, temporal-led terms. So workflow is what you expect a normal workflow. It's your business logic, and it handles different tasks and branches and go, hey, do this task in order, and if not, do these tasks. Those tasks are generally called activities. Activities are generally tasks that you send to other services or do a bulk of work. And the reason they're separated is because you don't want your workflow to have all of this logic and all this stuff. Because the workflow just go, hey, run this activity, then that activity, and if not, run this activity. So it should be kind of very clean, and then you send to your activities, and those run the bulk of your work. So, for instance, like, hey, I want to deploy config, I send it to a deploy config activity. I want to check the health of the device, send it to a check health. And what workers are they do the work. So they're basically servers, VMs, containers, and stuff that you launch that connect to the server, and they pull down. They can tell the server exactly what workflows they're able to run and what activities to run. So you can have a worker do everything, or you have a worker kind of do piecemeal. Maybe it's really heavy computation, so you send on one worker, and the rest you run another worker.
And I assume, you have different workers spun up because you have gRPC PC. Maybe, you have a production environment and a lab environment. Maybe you have a separate orchestrate or, an entire temporal server, managing separate sets of workers depending on the environment, or have you mixed together lab and production?
I don't recommend mixing. I think, keep lab and production separate. It's, safe. You get too many problems in the interpersonal relationships there. But I definitely do, workers, what's really good about it is because, you spawn them to do the work. if you have some stuff that's very, you want to be in site or in region for latency, or just, want to backhaul all that traffic, you just put that worker there and you just tell the workflow, hey, I don't want to run on that worker for this activity. And then the server will tell that. And then so all you have is this very lightweight traffic of the results from the activity sent back, but all the computation heavy stuff, like let's say I'm pulling down 100,000 metrics from a couple devices and analyzing them. I don't want to do that from if I'm like, London, I don't want to go that to LA. I just do it within, a European metro.
So with this workers, you could also do concurrency control. Like I want to make sure that I only touch one of my two PE routers, or would you do this in another way?
So that way, and again, don't call me as gospel on this, but generally I try and do like a parent workflow and then have it run some workflows and stuff. You're trying to do like some locking mechanism where it's like some concurrency avoidant, like clashing. I generally have like a parent workflow that schedules these child workflows that run per device or something like that. Or if you, have a batch and then just, can do, or you can do it parallel, or I mean, concurrent, not parallel, but you can do concurrent if you just, have a parent workflow that just runs a bunch of Go routines and spawns workflows in that way too.
So you would do this more in the business logic, in the workflow logic, and not with the runner logic.
Right, exactly. I want that runner worker logic to be very single-minded and just go, hey, look, I generally touch activities to services, and then just have the services run that kind of single-minded logic and stuff. Generally, I do that to avoid just trying to write a bunch of activities and then trying to register like 50, 100 activities. I just want to run, register the services and tie the activities to them.
So the DAG space is getting a little bit crowded these days. We have, of course, Temporal, which we're talking about right now. We have the Dagster, which is more there. Well, Temporal is very, time is kind of their theme, right? You have long running executions that you stop and then you come back and pick it up, versus some of the other DAGs, which are very, start here, finish here sort of workflows with some handling for long-term events and multiple user inputs and that sort of thing. So multi-stage lifecycle seems to be Temporal's thing, versus Dagster, which is very data driven. So their documentation and everything they talk about is very this is the asset, and the asset is a JSON file or a SQL table that you created, and then we're going to describe what happens to this asset and what other assets it interacts with along the path, and then you have a table which tells you how much money you're spending on pies every month or something like that, right? Versus something like Prefect, which is very sort of an execution minded sort of thing. You see the kind of the differences in how the documentation is laid out and how they talk about things, and their worker / activity terminology and that sort of thing. So a workflow over here becomes I don't even know what they call it over in Dagster, but it's at the end of the day, you start some sort of process with some sort of input, or on a cron job or a webhook or something, fires something, and then that starts the adventure, and you end up with some sort of result at the end, and you want that to be repeatable every single time, to a certain degree. Like get me a list of all, like, are you doing any data work with Temporal, like pulling in lots of state and doing some checks or something like that?
Yeah, so I'm definitely doing lots of, so I definitely I run my entire ecosystem. So you can run all the bunch of checks. You can pull the entire metro, entire site and stuff like that, analyze it and pull the data through that. And then that's why kind of like I recommend to kind of like do like for the big kind of handed services that you want to do like batching or multiple sites, I kind of create a workflow, a child workflow, and hand that off to that and go, hey, make sure the site's healthy. And it's a child workflow, and then that has like individual activities and stuff if you want to. I just try to make it very modular and departmental, but I definitely do a lot of data analysis. I know, like Dagster and like Airflow and stuff. I know Dagster in particular was like a data analysis kind of workflow centric. Mine is definitely, I do some data analysis, but I'm not that kind of that strict pipeline where I'm just cycling through the data. I'm more of a service kind of, modular kind of orchestration. So I really care about working through the services rather than working through just pure data.
Mm. So there's a general theory in which, you've accepted a framework into your life, this time it being temporal, and then you have a certain set of dependencies, some libraries that you use and that sort of thing. Have there ever been any times where you come up against the grain of the framework where maybe it's not conducive to something that you would like to do? Any cases like that in your mind? Like,
Um, it's more on less on the framework part. It's more on just setting up the self-hosted and stuff like that. You get temporal filter, great. I'm not dissing or anything like that, but how some of these companies make their money is they have a service and they run the service on cloud. And the reason they're on cloud is that way it's the architecture is all the same. They don't have to worry about people on-prem solutions having completely different code or versions or software and metal or like different types of metal. So they run their stuff on the cloud and they do support and stuff like that through there, which is fantastic. I've talked to them, great. Doing on-prem, they're doing much better, but there's still some you have to dive through the weeds on some things to get it fully working on-prem. So I feel like that was like the words of temporal right now. As far as the code, not really. Signals and queries are amazing. I absolutely love them. And they were actually insanely straightforward, like easy to get set up, which I thought was not going to be the case.
tell us more about these signals and queries.
Yeah. So generally, so when you have workflows, so I kind of go through the bigger, I'm talking about workflows and workers. So the other side piece of temporal is the server, which basically takes requests in for workflows and then finds the appropriate workers and keeps track of all the states so it can replay. That's why nothing of the states on the workers is on the server. And then you have a client, which is, it could be just, API that calls the server, says, hey, execute that. It could be a CLI or whatever. And if you want, and when it spins off a workflow, you can have it just run and, and eventually return. But if you want to interact with the workflow in some way, there's a couple different ways to do that. So we'll talk about like a query is a way just to get state from the workflow. So an example I use for signals and queries is getting a device diff. So I can run a workflow and then from a CLI and then have it, get a diff somewhere in the workflow, it'll get a diff. And so I'm doing a client, just querying that state. And eventually when that state returns, like, hey, true or not null or something like that, like actually returns a string, the diff, I can then show that to the user and go, hey, look, that's the diff. And I can query the state. And you can do it for a lot. Like, hey, you can do the progress of the workflow and query that. So you constantly update the workflow. Hey, it's on this step or on that step or something like that if you want. As long as it's serializable data, you can pretty much do anything you want, send back and forth. Queries, though, are just purely read-only, right? You can't modify the workflow for good reason. You just want to be able to read data and not change anything. If you want to change some state, that's where you run a signal. Basically, it's the client telling the workflow, hey, this is something, this is a message, right? So, and what I really like about Temporal is it's automatically blocking. So when you put a signal in the workflow, it'll stop, wait for that signal. So it's really helpful for the config diff because I just go, hey, I query a diff, and then I'm gonna, have the user review it and either approve it or not, and the workflow is gonna pause and go wait for that approval, and if it approves, continue on. If not, it just exits and all good. And that's a really easy way to get that, just at least that manual verification step. Or you can turn that to two-party. You can turn that to JavaScript and put on the web and stuff like that. But it was like 4 lines of code on the workflow part. So, which was, I thought it was gonna be like, oh man, this is great, but it's gonna be complicated. Nope, pretty simple.
Which is really interesting that you're able to exactly have a block the workflow and actually finish it off. And this could take, a very long time between, maybe you have a bunch of these little workflows that haven't finished up, and then somebody comes along and has to, do manual approval or something like that, right? So you can have like a stack ready for them to review.
Yeah, and because it's signals and queries are all in the state database, well, in the server database that handles the the state for durability. If it's single sent, it still knows all that data, so it can still replay. And if a worker fails, that data is still there. It can still do durable execution. So if you have a diff that's coming through, and you're waiting for a signal, and person leaves for lunch or leaves on vacation, comes
Mhm.
back, you can still keep that going.
And we'll be able to pick up the thread basically without having lost any data. And this could be either a shopping cart, this could be network config, this could be anything that you can think of. So you can basically shoehorn anything you can shoehorn into code into having the temporal framework handle that execution for you, and you don't have to worry about the recovery. You get all these nice widgets like signals and all this good stuff. And self-hosted, so you don't yet run any of the cloud instances, or are you just running the open source hippy dippy version?
The open source hippy dippy version. Yeah, I mean, self-hosted, maybe some cloud. I'm not going to tell you exactly what our environment runs and stuff like that, but we've looked at both, and so um, yeah, both are capable though. That's the thing that's
Mhm.
great is they both do HA, and so the servers have clusters, and you can fail over if you want to and stuff. So far, yes, the self-hosted was in the weeds, but none of it's been lacking of like you need to do this or that. It's you can choose your adventure in that part.
That sounds really great. How about the visibility when we're talking about the server? So you can really see what is running, which workflow is in which state, or is it more like a black box?
It's definitely not a black box. So they have a whole visibility store tied to it in the UI, and so you can track in, and they do a lot of like histograms and stuff. So when you do a workflow, it shows that's executed, and you can filter on workflows and such and search, and then you can drill down the workflows, and it shows all the tasks and the time it took for each task to execute, and the status and all the metadata associated with that. So you can drill down to go like, oh, this task failed. Okay, what did it return or what did it not return? And oh, this task took 5 minutes. I thought it was only going to take 10 seconds. So you could definitely drill down into the UI.
Really nice. Could you also kind of pin artifacts? So later you can see the diff, for example, if you review some stuff.
Definitely. So anything that's like a task that returns something or like a signal or something like that is all recorded in that too as well. So if you have like an activity that returns the diff from the device into the workflow, it'll be recorded. So you can go back and go, oh, hey, Steinn saw the diff, saw that it was going to cause a major outage, approved it anyways, and so now we have the pitchforks and we know who to yeah, go for.
Nice.
Very nice. Now, have you, generally, like you have multiple ways to interact with Temporal. You have that built-in web UI that's on the cluster. You have you have a CLI application. Everybody loves their CLI. When it comes to using the API and
Thanks, Steinn Bros.
oh, we're back, ladies and gentlemen. So regarding interacting with I should get more internet. So regarding interacting with the cluster, we seem to have like three general, options. It's the CLI, which is all very cool, and we're very old school here, and we like our CLI. We got the web UI that's built into the actual cluster, and then of course there's the API. Now, when it comes to doing maybe a web application in between, or having some sort of local client that runs and sends the gRPC directly, where do you lean when it comes to making executable workflows that people interact with? Where do you send them?
Yeah, so the server is very kind of restricted in that because it's only showing what it can always do, so it's not customizable, which is good point because it's optimized and it works for that. So it's really good for viewing your executions and your patterns. There's a couple options where you can have it like abort or cancel a workflow, and then depends on your workflow logic how you handle abortions versus cancels. But that's really it. Like that's it. You can view and maybe that, and you can also just turn off that button to say, hey, no one can cancel workflows on the UI. So if you really want to interact or have kind of the immersive with the workflows, it's definitely via the API, and then do your own web web UI if you want to do that on the web. The CLI is much more for kind of, yes, you can kind of kick off anything you want on that, but it's much for like management of the workers and the server and such. Yeah, I
Mm.
try not to do it so caveman style on the CLI. So I'd say, yeah, just to stick with either CLI app that you wrote or GUI or something.
Right. So, basically when the management team comes to you and says, "Hey, we're gonna, we want you to stick this into service now and be able to execute this, that, and the other." Uh, if you're doing self-hosted, you're basically either going to, especially with a mix of cloud service and self-hosted, where you need like some sort of on-prem installed worker that's on a private segment that can talk to the cluster and then fire off the webhook or the grc pc request or whatever. Any particular guidance that you would offer people on that, or is it just good luck, kid?
Well, it's a mix of good luck, just the myriad of permutations now with
Mm-hmm.
self-hosted and cloud and such. I would say the cloud solutions are always meant just for server only, basically. If you have any on-prem stuff, I mean, the rest of your stuff, if it's in like EC2 or GCP or something like that, or Azure, like definitely, like just handle it like on-prem and stuff. But if you have on-prem stuff, it's your workers are on-prem, and then just the servers in the cloud. If you're doing like their, Temporal is kind of self, not self, they're self-hosted, their cloud solution. Um, what is nice about Temporal, though, and if you do in the cloud or stuff like that, is the data is it's all your code, right? So you only send data that you want to send to the server and such. So if you have any data that you don't want, and you can also encrypt it if you want to. You can encrypt it and then have data decrypted on the worker. So it's not like it's servers constantly pulling data or anything like that. It's nope, I code and I can tell it what to send and when and how and where. So it's pretty flexible for that. It's just a gRPC connection, so it's as long as you have connectivity, you can kind of get that set up.
Yeah, but I'm just thinking now. You said it's not all the time pulling data, but it needs to be able to all the time know which line of code is executed at the moment because it is reliable and it can continue at this line, if I understood it correctly. So there must be always communication, right, between the worker and the temporal server. Or how does it track
So
the state of the code?
right, so it doesn't track the state of the code. It tracks the state of what activities are returning and other stuff like that. So um, when it replays for the worker, it goes, "Hey, look, I ran this activity, so now run this activity on your, I was up to here, and I'll run this going from here's the state."
Okay,
Um,
yeah. So if the
so
workflow would crash, let's say I have a workflow running for 10 days, if it crashes, it starts at the next activity again.
right, exactly. So if the workflow crashes, the state of the workflow is captured up until X amount of time for all the activities and stuff that you return. Like, Sally has deposited, 10 million Bitcoin into this account or something like that, and drawn. All that stuff is accounted for in the server in the kind of the state store, and then or event history. And then the worker itself just spins up and just goes, okay, cool. So anything that hasn't been sent back to the server in terms of like activities returning or workflows returning or like signals and such, if it crashes, yes, that state's gone, right? Because it's not scraping the code and going every little thing, but for the most part, that seems to have not really affected. Which is also make sure your stuff is item potent. Yeah, it's always a weird word to pronounce. There are definitely guidelines for if your stuff isn't item potent, to kind of make sure that it is with like some keys and tokens and such. But for the most part, just like kind of any super retriable workflow, try and make sure your activities are item potent.
Which is healthy advice for anyone, because you want to be able to run that sucker again in the middle of the night and you will not notice at 3 a.m. So, uh, weird workflows aside, you now talking about keys and tokens. Now, what's some general recommendations for, Billy on the gas station floor that's trying to implement this in his lab? Now, secret management is something that tends to get, abused and left for, the final pages of the book usually. So, got any pro tips regarding, vault usage or passing in tokens or encrypting data to ensure that, you don't have a container or some code blob somewhere with the SSH keys and the passwords?
Yeah, it definitely say is don't write your own encryption, like unless you are a security company and you're totally okay writing your own libraries and stuff. Don't use secret stores, whether that's Vault or like the key management stores that all the cloud providers have or something like that. And then encryption, they have a codec server that you can run, but it's your own codec server. They basically just say, hey, we have a plugin for a codec server, but run that. I think John on the Slack was talking about doing Vault can actually do encrypt data and decrypt data. But yeah, most of it is to the workers and stuff like that. It's TLS because it's gRPC. So and you have TLS, and then if you want, you do MTLS. So how you handle those certs with PKI is is your own prerogative. But again, that stuff is use what's widely adopted and widely vetted when it comes to security. Don't try and roll your own.
Yeah, apparently, some of the, from going through some of the Slacks, some of the first questions are basically how do I pass into the workflow, the host name that I want to interact with, and then the password, and then of course you get into the whole that's that's not going to be very deterministic what you're working with there in that workflow, buddy. It sounds like you're connected to a remote host and trying to pull some config there. Maybe put that inside of an activity and try and follow the rules, but. Okay, so aside from general, best practices when it comes to, securing your tokens and that sort of thing, anywhere else that you would recommend or some pain points while you were on the way?
And it's frozen again.
It's frozen again. And we're back. Thank you to our sponsor. Nothing. It's what you worry about at night. Now, tell me about some of the horrors that you've experienced. Is there anything that someone who was coming new into this with a network engineering background or not, that you would be like, hey, watch out for this, kiddo?
I think it's more, and you kind of touched on with the passwords and stuff. It's more, this is not a a low code or no code. Just follow these easy steps, and everything's kind of integrated and stuff like that. This is a systems approach is made for SDs and programmers and stuff. So you really have to dive into the kind of that world. It's definitely I had to think about hey, dependency injection and other stuff like that. And I had to think about, my testing frameworks and all this stuff like that to kind of get it through. And like passwords, oh, I'm going to have a user log in on the client and then type in their password. And it's going to sound like, oh, well, that'll get shown in the server because it's not encrypted. So do I encrypt it? And they're like, no. You should have the service that is the endpoint, have a key and a service account and send that too. So it's like, yeah, authenticate on the front end and then have all your services already have authoritative. And stuff like, it's stuff that is, a network engineer, because that's what I am by, trade, trying to go, oh, okay, I have to learn about systems design now. I have to start thinking with that. So it definitely is a learning curve for that, right? Like definitely you're not going to go like, I know Ansible and then go straight into this. It's going to be, oh, I have to think about all these services and systems and, how they interact and stuff and, theorem and all that stuff like that.
So, like, if we bring it back, just, from the start of the conversation, I mean, the reason you would go into a framework like this, like Temporal or DAG or something, is the fact that as soon as you're interacting with more than one external system, so basically, as soon as your script goes from interacting with a single switch to interacting with ServiceNow, a Netbox, and some sort of orchestration platform, one of those three things is going to have an error at some point, and how you recover or alert and actually, continue the workflow from one of those errors without having to build a super customized script for every single thing that you want to do, you're able to pour basically your heart and soul into this framework, follow the rules, and then you'll have some durable, repeatable execution, and you'll be able to configure that switch or send this request or close this incident ticket without worrying as much and without trusting as much of your own code as you would if you were rolling on your own. Is that a pretty good, sales pitch for the kiddies?
Oh, absolutely. When my coworkers go, oh, okay, well, how are we handling retries and all this stuff like that? I'm like, I don't have to worry about it. I can set it. It's a nice, easy, config part. It's a struct and go, and just, once you set the activity options or the workflow options, you can set how many retries you want and stuff like that. We'll say for keep in mind, if you want it to fail immediately, then you set the retries to none, like, hey, no retry. Or if it sends, because if an activity returns an error, it's going to keep retrying until it's out of there. So you have to actually float that error back up to the workflow to actually fail the workflow and stuff like that. Because again, it's assuming that an error could be like a network error, a transient error. And that's why I want to retry for the durable execution. So you have to just be mindful of that, of like, the activity failed. oh, I actually now have to make sure that, the workflow fails if I want that activity to really stop the workflow. Else it's going to just go, yeah, I'm going to keep retrying until you tell me not to.
Which is kind of what you need as soon as you go, especially starting directing at scale of more than one system. Basically, you're asking for trouble because that script ran real well on your CLI when you're directly connected to the switch, on your local network. But as soon as you're in the real world and somebody has a config lock somewhere, or maybe the Postgres SQL server times out, or God knows what, you do not want to be handling all that on your own and having to go and then trace back the previous step in your script and delete. Oh, you created something in NatBox in the previous step. Well, you can't run it again because you already created it in NatBox. Oh, well, now you got to go and delete it by hand and then rerun it on the CLI and press enter. So, you get this durable framework that you can have, especially talk about if you were to grab Streamlit or something really hip and cool that would handle a web UI for the kiddies, basically, where you do some input fields and that sort of thing, or you could do that in ServiceNow, and then you have that shoot the request over to our friend Temporal to handle the actual execution, and then you could have like little in-between checks where your little fancy web app checks on the state of the execution and shows that it's all green at 100% at the end, and bam, Bob's your uncle. You're a software engineer. Congratulations, have $1 million. So the real question is, let's say that we have all of this. We're all happy campers. There was one thing in my notes here, like you are very religious about the saga pattern. So if you could tell the viewer about how you're implementing the saga pattern in Go and what benefits you're getting from it, please do explain.
Yeah, I touched on this briefly before. So basically, the saga pattern I handle for rollbacks, and this was rollbacks was like the main thing that kind of led me to look at workflows, because I'm like, oh, Ansible, how do I roll back? You literally search Ansible and rollback, and you might get like one hit in the entirety of Ansible, and it goes, oh, well, you can create a custom Python module with my DSL, with the Ansible DSL, and like, well, how do I do that? Well, here's how to add a VLAN. It's like, oh, okay. So like, I'm like, I can either figure out how to reverse engineer and create, that, or I can find a solution that has it, and if else, then just do this. And that's what I kind of, found Temporal was like, okay, cool. The durability was life-saving, because I would have done, oh, this is awesome. Now, how do you make it durable and reliable? I'm like, no, okay. I'm out of my field. So luckily that came naturally. That's a big benefit, but that was not my main goal. So when dealing with rollbacks, how do I organize the logic for that? And so, I could have, there's a bunch of different ways to do it. You could have like, you put steps into like a list, and you execute those functions in reverse order after the end of the function if you do errors, and you kind of keep adding them back. But with Go and defer on functions that it runs in reverse order for defer anyways, that you just, hey, for this activity, if it failed, run a defer and run this activity. So by the time you go through all the activities, it defers, it all just works back up the defer stack and then automatically cleans up. So I don't have to worry about keep adding to lists and check the list and keep adding like funcs and stuff. Like that's always not the the most. You might use reflection in Python or something like that, and so it's not the most straightforward, especially for a novice software engineer like myself when I'm dealing with reflect or unsafe. So right. Okay, cool.
Which is, without turning this into the Python or the Go podcast, whatever the hell we are, doesn't matter. Now, especially, when you talk about the ability to actually, defer this execution, and, anybody who goes through Software 101 and C, you learn to do your little word processor. And the second thing the, professor makes you do is make the undo function, which is just, hey, you have a stack and you keep adding, oh, this is an operation. Let me add it to the stack, add it to the stack. Oh, I need to undo. I take a plate off the stack, and then I do the reverse function of whatever added the character. So I just remove the character. I create the VLAN, I remove the VLAN, I deploy the config, I roll back the config to the previous, especially if the device, like, oh boy, if you have a Cisco XR or Junos, something that has configuration reversion built in, and you have the ID, like, rollback is so much easier than, rolling your own diff between, iOS Classic, and you're looking at it going like, well, I can use the archive feature, and wow, I hate my life. Great, it works half the time. So especially, when it comes to rollback, I mean, Ansible is kind of a joke unless you, really implement that thing like super tightly, yourself, and the code, like the playbook becomes disgusting in 20 minutes. I have one of
Just
those.
reload the box.
Yeah, just reload, just nuke everything, get a new job immediately, But when we have stuff like, around the corner, like, do you work at all with Terraform or like any other stuff at your org day to day?
I don't. We have a partner team and stuff that deals with
Mhm.
the servers and stuff, so they work with kind of those things. I like Terraform.
Mhm.
Dinesh hates when I say the term promissory or something like that, or stuff like that. I'm like, it's similar, but networkings are much more. When dealing with hardware, you have much more states that are unknown at time of deployment, or very hard to model or validate. You can't really unit test. If hardware fails, or all these protocols that we have. So I am less of like, hey, here's declarative, push it, cool. Okay, just keep pushing it, keep pushing it.
Mhm.
Now you can definitely hook in like Terraform as an activity, and then have like other activities to kind of check and do something else in case something changes. Just like you can hook an Ansible. If you have an Ansible runbook and then it's cool and you need to do extra stuff, just put that into activity, do an API call to your Ansible server, and have it run that runbook.
Mhm.
So
And
you can kind of you can put components and mix and match stuff with it.
and that's kind of the beauty of it. I mean, you get to pick your language: Go, Java, Python, even .NET. Apparently, there's some people still out there. Good for them. Uh, so, not going to hate on the Java people when it comes to .NET. Well, I mean, it's Microsoft Java. That's what .NET is. I don't care what you say. Um, so you get to pick your language. You basically just execute your thingamajiggy, and you can work on anything you want. You can use whatever paradigm you want. You can use, Python unit tests to do some pre-checking. You can use some nuts. If we got to talk about our nuts, Urs. That's the network unit tests. Please do not ban us. This is not a PG podcast. So we get to play with the nuts, and then we also get to use Terraform, use Ansible, whatever makes sense in the job. And of course, inside of that particular workflow or tiny little activity, so long as you have something especially reversible, if you're using the style pattern, or, on fail, call this Python, reflect bullshit. So long as you have a way of undoing your particular, path that you went through the DAG, and you have a trace of it, I mean, Bob's your uncle. You're going to be a happy camper. And this is, of course, a more, you get a lot more power and flexibility. I assume you would get, the best of both worlds would, of course, be some sort of Git Terraform combination on this side of the house for deploying configs and that sort of thing. And then layering in between that the pre and post checks of, hey, this is what a service looks like now. Maybe I'm taking it offline. Then I'm doing this by doing these config pushes through Terraform or something, box X. And then the box below that executes afterwards is the, yes, we're going to bring it back online, doing maybe Terraform or Ansible. And then finally, some nuts and some unit tests at the end. And that can kind of be an end-to-end chain of a certain, like, draining the link is usually the default example for this, link draining for BGP peering and that sort of thing. But I kind of just want more. I've seen how nice the Kubernetes people have it. They got their Argo CD and they just smile, and then it doesn't. Oh, it's not conforming. Oh, wait, I forgot to put a comma, and then it just works. And then they go home to their kids. Well, we're kind of mixing together and having to do all these pre and post testing, and nothing's ever the same. Versus somebody who can spin up a million Kubernetes services in like 15 minutes and then just go home. So, like, if you could have anything, Ryan, in the world, like, magic wish, like, would it be Argo CD for network engineers, just that would work? Or what's your wish list?
So, yeah, I would wish, for that, a dog that can talk, and just myriad of other things. But, at the end of the day is, when we're thinking about that, the promises of these applications are completely different, right? Like, you're deploying 50,000 Kubernetes applications, but each application has been thoroughly unit tested, modeled, everything like that. And it only works in like, a couple different ways. The networking, you have BGP, you have, do I have transit, do I have PNI? Do I have IX? Do I have route policies here? Do I have ACLs here? Do I have, is this grained, or is this link failing or erroring? There's so many permutations that happen that make it almost, very hard to model. I'm always a kind of point of like, modeling is freaking hard. Don't just people say, hey, model your network and then deploy it and everything should happen perfectly. I'm like, no, model is great, but test because modeling is freaking hard unless you have like 100 PhDs and stuff like that. So it's hard to it's yes, BGP is unit tested on the box, but not your permutation of config and traffic flow is not unit tested and stuff like that. And so it's much more. Yes, I would love a nice, easy point and click declarative push and that, but that's not the reality of networking and hardware today.
Yeah, I think it's also definitely a huge distributed system, right? If you do something on the BGP on the left side, it can totally affect everything on the right side. So the Kubernetes is
You're
more,
basically inside the box the entire time,
yeah,
right? You're inside Kubernetes has ACLs, right? But, unlike our routing ACLs, they're inside the box. Your routing ACL is inside that particular box, but it's all dependent on talking to other autonomous systems, other engineers, other people you can't control. And I mean, in theory, we should be able to get something working for a single vendor, right? Some sort of magic. They do networking on Linux, like servers run directly connected to the internet, doing their own peering, like Linux boxes. They have found a way, kids. Like there must be
yeah.
some
But
way to do this.
they solve a lot of things with abstraction or with overlays, right? Put another sidecar and then another sidecar and then use service mesh and then use gRPC tunnels between. And so there are so many layers. And the thing is, we are in the bad situation that we have to deal with the box, with the hardware. So I think that is what makes it difficult for us and the vendors. I cannot say the vendors are not to blame. They definitely make our network automation journey more interesting.
Very interesting. It's a journey. So, Ryan, besides, beating on the vendors, which is kind of the dead horse of the network automation community, and you want talking dogs and world peace, anything else, that you see on the horizon that, any projects, anything you want to push or tell people about?
Yeah, I'll definitely do the plugs. I just want to get back to keep in mind, like, when Kubernetes, we're talking about like, Linux networking and stuff like that. It's a very different mindset because you're looking at it from, a graph theory point of view, right? You have a very constant set of, edges and, very set of nodes and directions of the edges to the different nodes. It's not a myriad of things. It's generally, hey, default routes or small routes or, very much one hop, two things. When people go cross networks, for instance, that's what I love, when you have large companies and they generally go, oh yeah, we automate our class networks, or most of our class networks are less automated. And it's like, okay, but you have three directions, maybe a service, an edge, and maybe a host layer, and your class. So you have nodes with two edges, north and south. The modeling part of that is probably the easiest on any network possible because it is just a fabric. Once you start getting into your backbone and your core routers and other service layers and stuff, people go, oh, that part isn't automated. It's scary. It's difficult. All of that. So I've seen that story several times. Going, yeah, okay, cool. Now let's do the hard part. And that's when we start getting to this whole thing mess of like, oh, now we have to figure out checks and what traffic happens over there and other stuff. As far as projects and plugs, yeah. So I'm leading a working group in the NAF Network Automation Forum to do like a framework for network automation. So basically, I'm lazy. I want multiple people to help me out in this endeavor of kind of building a roadmap that I can definitely cannibalize and use myself. I don't know all the answers. Hey, that's another thing to wish for. Knowing all the answers in the world, that'd be great. Assuming my head doesn't explode. But yeah, I think that's a really cool project because it's helped building this public documentation resource that people can go and iterate on because I'm very much, I take advantage of things like Temporal. I take advantage of other software and stuff that greater minds have created through this iteration and stuff. I like, oh, awesome. So let's keep doing that because that's going to keep getting better and better. And there's I think automation is at this awesome kind of jump start of, hey, we got some great ideas, we got some kind of knowledge, and we've got some experience in our belt. Like, let's start building cool things.
Yeah, building cool things. Oh boy. And the cooler the thing is, the worse it's going to feel when you have to go out and shoot your darling in 6 to 12 months. And, oh, we built it so well. Oh, wait, it doesn't serve the business function anymore. Well, he's my dog. I'm going to put him down. uh, So we'll link some links for anyone to go check out the NAF, the Network Automation Forum. There are so many Slack channels, you're going to have a really hard time finding it without the specific channel. But there's some very interesting work going on in that working group. So I just like to come in every now and then and throw a grenade and be like, no, it won't work. None of this will work. We should give up and sleep under our desks and get divorced. That's what we should do. But luckily, there's some very positive people there that, there's light at the end of this tunnel, or at least fire. Maybe it's fire. So
we'll find out, though. We'll
Yeah, absolutely. Urs, anything you want to plug or leave, our wonderful listener that stayed with us until the end? Congratulations.
Yeah, good for them. No, I just really like the discussion. I really like all the features, and I really want to hope that everyone who listens wants to have more than just simple scripts and doing some CLI, so that they start to think about the whole workflow process or pipeline or whatever wording you want to use. And yeah, building doable, stable network automation who does not only cover the happy path. So yeah, happy path, always easy, right? We can do this with some Python or Go lines. But if you really want to make something reliable and also maintainable, definitely don't do everything by yourself and use the tools that are around.
That sounds like a really good takeaway. And thank you, dear listener, or viewer. I don't even know, man. The pretend to professional podcasting isn't real, But this wonderful conversation came around because Ryan was very active on the Network Automation Forum, and I like to exploit people for their knowledge. And this is one of the topics that is covered in the network automation landscape. And now we can basically check off Temporal. So that's one of like 98 things right now. So, it's only 98 hours to go. So, we're going to be done by Christmas if we just do this nonstop. It's great. It's great. I don't need to see my kids. So again, Network Automation Forum, go check out Temporal or some of their alternatives like Dexter or Prefect or even good old Airflow. It's kind of old school right now. You do get a lot of, hey, Richard Stallman, what are you doing? Looks, at you because you look like an old Linux if you do Airflow, but I won't judge you. And I think it's great. Step one is, of course, getting that creation script, right? Like that's where everybody's got to start at the end of the day. It's the, hey, I provisioned a VLAN on the switch and I registered it in NetBox, like that simple happy path. But that, as Urs and Ryan have mentioned, you got to test more than the buy button. You got to test the cancel order. You got to test the rollback, and having the tooling such as Temporal with this very, very supportive rollback way of doing rollbacks, especially around long executions, right? So that's the takeaway of today is, when I need to do something that's more than hey, I run the script, I do this in a single 5-minute window. When I need something long, I need something persistent, safe, and of course, easy to debug. By the way, that's the last thing. It's actually on my notes here. Like, how would you rate the debugging experience compared to, anything of your other tools? Like how, if something goes wrong, how fast do you feel that you're able to solve it?
Oh, pretty fantastic because it's built kind of on Observability 2.0, so it has the old hotel plugins and stuff. Like, you can put standard logging in, and, structure logging, not standard, structure logging and stuff like that. So you can really, the server also has all the hotel stuff. So you have a wealth of, logs, metrics, traces that you want to do through. So you definitely can get all the data and all the visibility you want out of this and more. You have way too much if you want to.
That sounds like an
That's nice.
8.9 out of 10. And, I will give, however, one competitor a lot of points, which is Daxter with their Grafana or with their actual graph, like the UI component. It is so good because they have this metadata thing where you can basically like have SQL or, actually the actual SQL command that you're running or the tables or whatever. Like if you want to display an image, whatever, like you click the node that says, my VLAN data, right? You click that asset node and then it just shows you that data and has little checks and shows you which VLANs are not conforming or, whatever test you want to write. Like the comfort level with showing other people what's going on, like having it on your machine, really great. Having it on the Temporal server, I found it a little raw, the Temporal web UI compared to Daxter at least, and Prefect. Prefect and Daxter seem to be a little bit more shiny, and we do like shiny, but we will cover those. Everybody likes shiny, especially your manager when you show them like this is the VLANs that are failing or something like that, and you got to send them a link to something. Do you want to take screenshots or do you want to send them to the shiny portal? I say shiny portal every time. That's how
I
you
want
get
to
funding.
send them the gRPC payload.
Yeah, send them the raw XML.
Yeah,
you parse
this,
the
raw
you son of
and XML.
Good luck.
Oh God.
Half of it's YAML in the middle that I converted for funds. So good luck parsing this. Bye. And it's above the ChatGPT token size, so you won't be able to get any help on this. Have a nice day. But wow, we need like a closing segment, which is like, either unpopular opinions or something like that, because I do not know how to end things. So, Ryan, do you have one unpopular opinion that you're afraid to share? No judgment, like regarding technology or life. You can tell us.
Yeah, I'll share I don't think it's an unpopular, but be simple-minded in life. There's so much. The simple things are great. Especially watching a toddler. I gave him an apple, and he is over cloud nine with this apple. And then he found his, then he found like his stroller. Like the dude's like, yes, be like that. Have that. Yes, go for your goals and reach your dreams and stuff like that. But try to focus on simple-mindedness. It makes life just so much more enjoyable when you hit all your happiness goals right in the morning. As far as the unpopular opinion is, network automation is just like systems. You're gonna have to get into that SD mindset. You're just gonna have to get that software engineering mindset to build good on network automation systems. It's not it's not bespoke. You leverage what the rest of the community has, and dig into it. It's hard. It's difficult, but honestly, if you went from VLANs to MPLS and networking and all the different vendors and stuff like that, you could do this.
Well, there you go. Especially with all the tooling. Yeah, Ryan believes in you. That makes somebody, right? Yeah. Your mom and dad definitely don't. So, in conclusion, we're going to wrap this up. Thank you so much for your time, Ryan. We're going to leave links at wherever somebody's watching this. Hi, Mom. Thanks for watching. I think we have one viewer. I think it's just my mom. So links in the bottom. Thank you so much. And the unpopular opinion was pretty good. But he's going to get some hate in the comments section. They're trying to turn my network engineers into software weenies. Back in my day, men were men, cats were cats, and VLANs were VLANs. Now you got VXLAN. So, in conclusion, thank you for joining us. And that's a wrap.